Greetings from Cadnexus. Cadnexus is a global provider of interoperability software for collaborative multi-CAD to CAE environments. What you're about to see is a product demonstration on our CAPRI to MATLAB interoperability gateway that connects our CAPRI turnkey product into a MATLAB environment, which is provided by MathWorks. A little bit of background about Cadnexus and our capabilities and our solutions overview. Our solutions enable organizations that rely on simulation-driven design to integrate key engineering tools and processes to improve product quality, accelerate time to market, and reduce engineering inefficiencies and costs. We also offer a full suite of professional services that provide a full scope of training, mentoring, custom development, implementation, and turnkey solutions. We have the ability to customize the services offerings surrounding your pain points within your product development process. Cadnexus is also partnered with many large and small software and strategic companies throughout the world. Here you'll see a list of some of the folks that we are partnering with today. What you're about to see is a demonstration on the CAPRI to MATLAB interoperability gateway. The Cadnexus MATLAB CAPRI Design Toolbox provides MATLAB users with a way to access native CAD models from within the MATLAB environment. As you can see, this will enable you to do optimization, design space exploration, and analysis directly on the CAD model while maintaining associativity between the analysis model and the CAD model itself. Here is a sample of some customer testimonials of folks who have integrated our CAPRI CAE gateway into other tools along with MATLAB. You can find all of this information and all of our testimonials and other products, services, and offerings on our website, cadnexus.com. Next, you will see a demonstration on the CAPRI to MATLAB interoperability interface. Thank you for your attendance, and we hope you enjoy this demonstration.
In this demo, we illustrate a simple interaction between MATLAB and CAD using CAPRI. Having the CAD window open is optional, but we use it here for display purposes. More complex design and optimization workflows can be built using CAPRI functions in M scripts. So we can call methods on the CAPRI API directly from the MATLAB command line. So the first thing we typically do to establish a CAPRI session is execute a uStart. And once a session has been started, we can then load a model. So what I'm going to do now is load the basic bracket model into SolidWorks. Assemblies can be loaded by using the top-level assembly name. So shortly, the bracket model will be displayed in SolidWorks. And the model is loaded and is available to the MATLAB command line interface via CAPRI. So now we can generate a figure, display the model in MATLAB. Queries on the topology can also be performed to obtain mass properties and other information needed for design and analysis. And what we're trying to do is illustrate that you now have access to all of the geometry and properties of the model or assembly available to you at the command line in MATLAB, so that you can drive those parameters using an optimization or any number of analyses that you might want to do. Here's the number of volumes or bodies in the loaded model. This can enable display of specific bodies in a multi-body model. In our case, there is only a single volume here. Thus, the answer is 1. So as we plot the model, what we're getting here is a tessellation, a watertight tessellation from that volume. And this tessellation is guaranteed to be watertight. And rotating this, we should be able to see that it is indeed the bracket model that is being displayed in SolidWorks. The tessellation quality can easily be controlled by a number of parameters that are taken to that call, essentially to control the density or the coarseness of the triangulation. Next, we'll query and modify parameters in the model and observe the effects. So here, param_out is a sample M script which gets the parameter names and values. This script can be used as an example to build, for example, an optimization workflow, or as the starting point for it. And it returns a name, info, and value for that parameter set. So we now look at pName, which provides a list of real parameters. Others are filtered out. More detailed information on the parameters is also available. This includes the types, units, dependencies, and expressions, and so on that are needed for design. Looking at the p-value array, we get the corresponding values for those parameters. And now we're going to do a parameter update call for sketch 2. And we want to reset its value from 0.127 to 0.025. And again, this interaction is brokered through CAPRI. So there you have the increased radius in the hole in the bracket. Essentially, CAPRI underneath called for the change in diameter value on that parameter and instituted a regen of that part. And here's our bracket in MATLAB space before and after the results of the parameter update. And changes can be tracked and rolled back. The user can easily configure the ability to do this. Since we're done with our model, we want to free up resources that have been allocated to handle it. So the first thing we do is call release model, and that closes the CAPRI session. And to completely release any remaining resources, we execute a use stop. And that concludes our demo.